it's possible when you set it up to set it up something like this. You can name your triangle and your circle together with the same set of points. Okay, that triangle is said to be inscribed within the circle. And when all the points lie on the circle, but every interior point of the triangle is contained in the interior of the circle as well. And so in looking at this, we're told what the ratio of these angles are. We're told that they are 10 to 3 to 7. You can think of those ratios in two distinct ways. You can either think of them as part-to-part relationships. If that's the case, then you're maybe thinking that A is 10x, B is 3 times some common multiplier x, C is 7 times that same multiplier. If you're thinking of them in this way, what do you know that all of those angles have to add up to? Sum of the angles is 180. And so if you add these together, you get 20x equals 180. Divide by 20, you get x is 9. So you could plug these in and actually come up with answers for this. Your angle A is 10 times 9, or 90 degrees. Angle B is 3 times 9, 27 degrees. Angle C is 7 times 9, 63 degrees. So that's one way to find these angle measures. You could also think of in terms of part to whole. You've heard me say this a couple times. If you're thinking in terms of part to whole, then if there's 10 parts, 3 parts, and 7 parts, how many total parts are there? 10 plus 3 plus 7 is 20. So you can think of each of these being a fraction of the whole thing. So A is 10 out of 20, or 1/2 of the whole. B is 3 out of 20. And C is 7 out of 20. And so if you multiply each of those by the whole, and you know the whole sum of the angles is 180, you can take half of 180 is 90 degrees. 3/20ths of 180 is 27 degrees. 7/20ths of 180, 63 degrees. So it doesn't matter how you solve it, part to part or part to whole, you should come up with these angles. Okay. How many of you were able to get this far in the problem? Okay. Now, what kind of a triangle are you dealing with here based on the angle measures? It's a right triangle, right? Is it drawn up as a right triangle? No. So it might be helpful to draw it as a right triangle. And the reason for that, if I go in and redraw this triangle, and I know that my angle A is a 90-degree angle, okay, when you're inscribing this triangle in the circle, what has to be true if you have this right angle inscribed in a circle? The side opposite that right angle is going to be a what? Yeah, it's a diameter, right? It's going to intercept a semicircle or be inscribed in a semicircle. So that gives you some additional information for this problem, because now we know our angle B and C are going to connect across this diameter, which we were told is 18 centimeters. We still have our angle measures of 27 and 63. But now, is it easier now or possible now to find our area? Yeah, because this is what we did in class, or last class, right? We did our right triangle with one leg, or one length. We can find the remaining pieces. So let's assign this to be our base and this to be our height. We can use the area formula for a triangle, 1/2 base times height, and just substitute in what we have. Okay, so our base, in order for us to solve for this base, we could use our angle of 63. B is opposite that, and we know our hypotenuse. So which trig ratio relates opposite and hypotenuse? So sine of 63 degrees is equal to opposite B over hypotenuse 18. Multiply both sides by 18 to isolate our variable B. And so we can make this substitution right here. 18 times the sine of 63. We can do the same thing to find h. Again, if we wanted to, we could have used 27. Sine of 27 is equal to opposite h over 18. Or if I stay with the same angle, h is adjacent to that, and I have the hypotenuse. So which trig ratio relates adjacent and hypotenuse? Again, we see it's the cosine. So we can set up the cosine of 63 is equal to the adjacent h over the hypotenuse 18. multiply both of those by 18 to isolate our variable. And so that can be substituted right in here, 18 times the cosine of 63. And so we're left with our calculation for this area. We can simply plug that in, 0.5 times 18 times the sine of 63 times 18 again, times the cosine of 63. And we've already entered a decimal, so we get our answer in approximate form, 65.53. The units are centimeters. It's an area, so we have to identify two-dimensional measurement, so it's square centimeters for that. Okay, questions on that problem? So again, once you identify the ratios and are able to identify that it is a right triangle, when you inscribe that, it is going to contain the diameter of the circle, so you can use that information just like what we did last class to find the areas. All right. The last problem, and this is